Okay, moving right along in our Algebra 1 review, we're going to need to remember our exponent rules, and we're going to need to remember what we do when we see radicals together. Okay, so these top three, 16, 17, and 18, are all going to relate to these exponent rules. In number 16, I see 2 to the 2/3 times 2 to the 1/2. Okay, and this is going to be one of our product of powers. Okay, I know it's a product of powers because I see my multiplication symbol in between, and I am multiplying two powers with the same base of 2. So when I look at what the rule tells me, if I'm multiplying a to the m times a to the n, that just means I'm adding those two exponents together. My exponents in this case just happen to be fractions. Okay, so my final answer is going to be 2 to the 2/3 plus 1/2. I'm just adding those exponents. The only thing this time is I have fraction exponents, so I need to remember how to add fractions like 2/3 and 1/2. In order to add these, I need a common denominator. With 3 and 2, my common denominator can be 6. So I'm going to make both of these fractions have the denominator of 6 using multiplication. 2/3 is really 4/6, and 1/2 is 3/6. So when I add those together, I get 7/6. This is my new exponent. It's not my final answer. My final answer is 2 to the 7/6. Okay, moving right along to number 17, I see that same type of problem inside the parentheses, product of powers, where I'm multiplying y to the 2/3 times y to the 6th, but then I'm raising that final answer to the 1/4. So let's start with what we know. I know that the inside of the parentheses is going to be y to the 2/3 plus 6. And if I want to add these two numbers, again, it might be helpful to think about 6 as a fraction, okay, or 6/1, and then I'll get my common denominator, making it 2/3 plus 18/3 or 20/3. Okay, so the inside of the parentheses is going to be y to the 20/3. Okay. But then I'm raising that whole thing to the 1/4. Okay, that looks something like this, where I have a power to a power. That's just telling me to multiply my exponents. So 20/3 times 1/4, multiplying my fraction straight across. 20 times 1 is 20, 3 times 4 is 12. This is my new exponent, y to the 20/12. If I wanted to reduce that, I can, to give myself y to the, if I divide each of these by 4, I would get 5/3. Okay. Number 18 honestly looks a lot like one of the problems we did on the front of this worksheet, where you'll want to write it in radical form first. Put your 27 as the radicand, your 3 as your index, your -1 as your exponent. Start with your root. The cube root of 27 is 3, but then we have an exponent of -1, which again, if we look back up at this little diagram, we're looking at our negative exponents. Okay, negative exponents aren't really happy where they live in a fraction, so they just want to move to the other side. Okay, this is going to turn into 3 to the +1 in the denominator, and we know that there is an invisible 1 on top. So this is actually just going to be 1/3 for our final answer. Okay, moving right along. Number 19, again, is very similar to what we did on the front page, so I'm going to let you guys work on that one. The square root of 45, we're going to break down into the square root of 9 times 5. Okay, you should be getting a final answer of 3√5. That prompts us into these next couple, though. Here's where I am multiplying radicals. And when I have a radical and I am multiplying or dividing them, they just have to have the same index, so they have to be the same type of root. Since here I'm dealing with both square roots, I know I'm good to go. I'm going to simplify first. I'm going to simplify first and then do my multiplication. Okay, so starting with 2 square root 8. I know that 8 is the same as 4 times 2. I broke it down like this because I can now nicely take the square root of this 4, which is 2. But there's still a 2 squished in front of it, and there's still a radical 2 after it. Okay, these two 2's are going to multiply together to give me 4√2. I'm going to do something similar with the 3√18. I know that 18 can be rewritten as 9 times 2. The square root of this 9 is 3, but there's already a 3 squished in front of it, leaving the 2 behind in the radical. And now my two 3's multiplied together gives me 9 root 2. Okay, finally, when I multiply my radicals, I'm going to multiply my coefficients. 4 times 9 is 36. I'm going to multiply my radicands. 2 times 2 is 4. And the square root of 4 is 2. That's getting multiplied by the 36 to give me 72 for that problem. On problem 21, I see a big square root of a fraction. Okay, and so I always check, can I take the square root of numerator and denominator? And in this case I can. The square root of 81 is 9, the square root of 100 is 10. That's all I can do with that problem. Okay. So similarly on number 22, if I look at numerator and denominator, in this case I can only take the square root of the denominator, but the numerator I can just leave alone. Okay, and these last two, we're going to go back up here to our rules. Again, with radicals, we're now adding and subtracting. They have to have both the same index, so the same type of root, and the same radicand, the same number under the radical symbol. So when I look at number 23, they're both square roots. They both have the same little index number, but these two numbers don't match yet. So I need to do some simplifying so that those two numbers match. Okay, so just like we did before, I know that 27 can be 9 times 3. And I like that because I can take the square root of 9 and get 3. But there was still the 2 in front, and there's still the 3 that we're leaving behind. So this is really 6 root 3. Okay, so now I'm going to work on the 12. I have my 3 in front still. 12 is the same as 4 times 3. I like 4 times 3 because I can take the square root of 4 and get 2. But again, there's still that 3 squished in front, and there's still the 3 left behind. 3 times 2 is 6. And I still have the root 3. So now what I'm left with is 6 root 3 plus 6 root 3. They both have the same index, they're both square roots, and they both have the same radicand, the number underneath the radical. So I can actually do the adding now. 6 root 3 plus 6 root 3, or 6 of something plus 6 of something is 12 of that thing. So again, similarly with your subtraction, you're just going to do your simplifying first. If my pen allows me to.